carefully, which was fantastic to see. You know, you get a prime is equal to 2 pi x plus 2 pi times 1,000 over pi minus x times negative 1. Almost all of you did that immediately, which is great. By far, the most common thing was 75% of you at some point made some sort of algebraic mistake, not only in this class, but in the last class. You can't take the algebra lightly because it will blow up in your face. You have to do it really, really, really carefully. If you misplace one negative sign, what happens? Boom! Boom. So in my opinion, if you're going to do this one from here, I would take that negative sign first and make it negative 2 pi times 1,000 over pi minus x, and then distribute this in, and then distribute it in. So you get a prime is equal to 2 pi x minus 2 pi times 1,000 over pi plus 2 pi x. It takes 2 seconds to write that whole thing out. Many mistakes come from not writing things out fully. So what do you end up with? A prime 2 pi x minus 2,000 plus 2 pi x. Some people get that sign wrong, and if that's negative, you get 2 pi x minus 2 pi x. All of a sudden, all the x's go away, which is possible, actually, because are you guaranteed to have critical points on a function? Can a function just be increasing? Sure. Can a function just be decreasing? Sure. So if you tried to search for critical values on a function that's just increasing, what would happen? There would be no solutions. If you tried to search for something that's not there, you would get a statement like 7 equals 9. Is that a true statement? No, thank you. I'm glad you had to think for a second on that one. Okay, so what do you end up with here? A prime is equal to 4 pi x minus 2,000. So you want the critical value, so you set it equal to 0. 4 pi x is minus 1,000. Yay! So you get 4 pi x is equal to 2,000. So you get x is equal to 500 over pi. This is where the function's derivative is 0. So the question is asking you, what are the critical points? So what do you have to do with that value? You have to take this value and plug it in where? The original function to get the y value. Do that for me right now. Or label. What two?
L and W.
L and W. So you might have L and W. So what function are you trying to max? You want the dimensions of the, what is the largest area? So you need to write an equation for what? Area. So the area of a rectangle is equal to what?
Length times width.
Length times width. That is a great start to this question right here. So let's keep on going with what we know. It tells you that the fence is a total of 1,000 feet. So the fence is all the way around here. So that's not the area, that's the what?
That's the perimeter.
What's the perimeter of a rectangle equal to? What's the perimeter of a rectangle equal to? 2L plus 2W. But we know the perimeter is what? 1,000. So my question to you, Kira, is which one here, in terms of the bottom equation right there, do you want to isolate L or W? Which one do you want to isolate?
I'm feeling L.
Does it matter?
No.
It doesn't. So if we isolate L, we have 500 is equal to L plus W. So what does L equal? 500 minus what? So what do you do with this now? What do you do with this? Plug it into the area equation. If you plug it into the area equation, you end up with 500 minus W times W. Now, why was it nice for us to do that substitution? Why was it nice for us to do that substitution? Well, how many variables do we have? We're down to 1. Area equals something in terms of 1 variable. Now, can we do 2? Sure. Is it a little different? Yeah. So when possible, what should we do? Go down to 1 variable. Now, we have our equation. We're back to the beginning of the same work we did for our last question. We want to find where this is maximized. That's where the derivative is 0, and where it's increasing then decreasing. So we're going to need to take the derivative, but before we take the derivative, what should we do to this equation? Distribute, yeah. So we know that A is equal to 500W minus W squared. Lizzie, what's the derivative of that? So on that one right there, here's our area function. Here's our area function. Can someone tell me what the domain of that function is? What's the domain of that function? What's the set of all input values? The input values are W, right? Or width. Can someone tell me what the domain is?
W has to be
Between what and what?
between.
What's the smallest value W can be?
0.
0. You have no width. What's the maximum width it could be?
499.
No, it could be what? If it could be 0, what could it also be? What's the other extreme? No. You have 1,000 feet of fencing. So what's the biggest value W could be?
498.
Nope.
1,000.
Nope.
500.
500. if the width was 0, would there be any length? No. And if the width was 500, sorry, if the width was 0, it would be all length, right? It would just be 2 pieces of 500-foot fencing. But then if you did 500, it would be the exact same thing. So would there be any area at 500 or 0? When you plug in 0, what do you get? 0. When you plug in 500, what do you get? 0. So you have 0 area, but the maximum W can be is 500, and the minimum W can be is what? 0. So W, just to put this in perspective, W has to be between 500 and 0. So here's the next question, though. It says, what if we had the same problem, but for some reason W had to be between 300 and 600? What if we had the same problem, but for some reason W had to be between 300 and 600? Then where would the maximum occur? Meaning, what W value would maximize the area? So if, do you remember what it is? Do you remember what it is? It's no, the area for this one is 500 minus W times what? W. Graph that for me right now. 500, and is it up or down? It's facing down. So there it is right there. And what's the maximum here at the middle? What is it? 250. Okay, so where is 300 and where is 600? Well, this is the W values and this is area. You have 300 right here and you have 600 right here. So from here, what happens? It goes down. So the area is max at W equals 300 from 300 to 600. 1,000 feet of fence and you made a circular pen. What's the circumference of this circle? The circumference equals 1,000. So let's say we had a circular pen. Jen, please turn around. Circumference is 1,000. Pi times diameter equals circumference, right? So pi times diameter is 1,000. So what does diameter equal? 1,000 over pi. So we know that this whole thing is 1,000 over pi. So therefore, what is the radius? What's the radius then? 500 over pi. What's the area of a circle, everybody? Pi times what? R squared. So the area of this circle is pi times 500 over pi what? Squared. So that's areas, that's 250,000 over pi. Type that into your calculator and tell me what you get. 250,000 over pi. 79, what is that? 79,000? Can't remember exactly.
Yeah, it's 79,000.
Okay, so that's what you get if it's a circular pen. Do you remember what our maximum area was over here? What's 250 times 250? 625,000. So if it's a square, you get 625,000 square units. What is it? Feet. But if it's a circle, what do you get? 72. So do this for me. 79,577.47 over 62,500. Do that for me and tell me what. 1 point what?
1.27.
27 what?
273.
3? So here's the cool thing. If you change a square to a circle, if the same amount of fencing, if you change it from a square to a circle, what percentage increase do you get? 27.3% increase in space. Well, better than space, I could say area.
Like always?
Yes. Correct. So if you have a square and you change it to a circle, it grows by 27.3%. Pretty cool. Same thing works in 3 dimensions. Like, what's the most efficient 3-dimensional shape in terms of area? Sphere. That's correct.